Warmest greetings, yokoso, to all of you. I'm delighted to welcome our distinguished guests and friends to this International Green Metals and Hydrogen Conference, the first of its kind to explore the important relationship between platinum group metals and the hydrogen economy, which will play a vital role in tomorrow's post-carbon world. We are so pleased that this conference is being supported by Japan's Ministry of the Environment, ITM Power, leading academics from Kyushu University, and our conference partners, Furuya Metals and Sibanye-Stillwater. We have more than 700 delegates registered for this event, and for SFA Oxford, it is a real honour. And as chairman of SFA Oxford, it's a great pleasure to host you all. As the ongoing pandemic has prevented us from holding this conference live in Tokyo, as originally planned, we wanted this online event still to make a strong connection between our delegates, the speakers, and the message about the urgency of addressing climate change. The actor and environmentalist Leonardo DiCaprio recently said, "Climate change is real. It is happening right now. It is the most urgent threat facing our entire species, and we need to work collectively together and stop procrastinating." In light of this, we would like to introduce to you our avatar, Gaia. Gaia was the ancient Greek goddess who was the mother of all life, and today she will assist me with hosting this conference as our goddess of ceremonies. So with no further delay, I will hand over to her.
Thank you, Stephen. We are holding this conference at an extremely important time for the future of our planet. World leaders and climate experts have recently met at the COP26 summit and have made some significant and far-reaching pledges in the global effort to combat climate change. While we cannot be certain that the promised net zero targets will be met, what we can be sure of is that the momentum for decarbonization is building and potential solutions are fast being developed. Today, our event will concentrate on one of the most promising technologies that will play an important role in a low-carbon future: green hydrogen. I am delighted to introduce our 5 leading expert speakers: Mr. Tokutaro Nakai, Dr. Katsuhiko Hirose, Dr. Graham Cooley, Mr. Takahito Furuya, and Mr. Neal Froneman, who will provide us with a fascinating insight into what could be the most important technological developments of our time to preserve our natural world, our way of life, and most importantly, our children and their future. We will now hear from these authorities in their fields: state policy, hydrogen adoption and production, and the mission-critical deliveries and refinement of Earth Platinum Group elements for emerging carbon-free end uses. Our first highly esteemed guest speaker is Mr. Tokutaro Nakai, the Vice Minister at Japan's Ministry of the Environment. Mr. Nakai graduated from the Faculty of Law at the University of Tokyo and then began his career in government by entering the Ministry of Finance in 1985. Having gained extensive experience across a number of government ministries, he was transferred to the Ministry of the Environment in 2011 and held several prominent positions before being appointed Vice Minister of the Environment in 2020. Today, he will draw on his wealth of experience to outline the case for global decarbonization and describe the significant steps Japan is taking to reach its decarbonizing goals. Before we start, I'd like to leave you all with a quote. And forget not that the earth delights to feel your bare feet, and the winds long to play with your hair. 中井さん、よろしくお願いします。
クリーンメタルと水素シンポジウム講演の機会をいただきましてどうもありがとうございます。環境省の事務次官の中井でございます。私からは日本の脱炭素社会構築に向けた取り組みについてということでお話しさせていただきます。本日3つの内容となります。脱炭素社会に向けた国内外の潮流、キーテクノロジーとしての水素や触媒についての環境省の取り組み、環境省として目指す今後の社会の方向性ということでお話ししたいと思います。それでは脱炭素社会に向けた国内外の潮流ということで、地球温暖化の現状でございます。これは過去数十年万年にわたるですね CO2 の濃度、これは自然の循環のメカニズムを持っておるわけですけども、産業革命以降のですねいわば異常値と言えるようなこの CO2 の濃度の上昇、これ特に100年50年 300ppm を超えたことがなかった状況からですね一気に 400ppm を超えると、こうした中で今気候変動がこの温室効果ガスにもたらされたこの地球の温暖化、国立環境研究所などがですね、行ったシミュレーションをここに掲げてございますけども、左側の今後この温暖化を食い止める対策をしなかった場合ですね、まさしくもう考えられないような地球の温度上昇ということで、大変なことになります。そして右側はこれからですね、なんとか温暖化対策を様々行って、この温暖化に立ち向かった場合ということで、これはまだこの温暖化は進みますけれども、今からやればこの温暖化に対する地球の対応力、ここが健康体になるということがシミュレーションでも明らかなわけです。こういう中で世界はですね、気候変動に対応するため脱炭素化に向けて大きなコミットメントをして世界が動いております。2015年ですね、パリ協定が COP21 で採択されました。ここにおける合意は21世紀にですね、温暖化を2度目標ということ、産業革命以降の2度に食い止めたいと。すでに客観的に1度ちょっとの上昇がもうすでに起こっていると。この中であと2度、1度の上昇で食い止める2度目標。それと 1.5 度に食い止めたいという 1.5 度の努力目標と。この2つの目標が掲げたわけですけれども、これを達成するために2度の場合ですね、今世紀後半の時点で地球が吸収してくれる CO2 の量と人為的に排出するですね、ものを均衡させる、いわばカーボンニュートラル、これを達成すると。1.5 度を目指すケース、これは今ギリギリですね、2050年の段階でカーボンニュートラルに持っていくと、こういうことになるわけですけども、2度と 1.5 度ということで、実はIPCC の報告が2018年に出されました。すでに1度の上昇ということで、これだけ世界中の異常気象、気候変動の災害多発しておりますけれども、あと1度の上昇の2度と、あと 0.5 度の上昇の 1.5 度ではですね、人間社会への影響が全く違うというですね、温暖化の災害等をですね、食い止める、その意味から言っても 1.5 度をやはり目指すべきであると いうことがですね、第5次の評価報告書で出ました。また、これは、この努力を続けない限りはですね、この 1.5 を目指さない限りは、この地球の温暖化が食い止まらないと、止まらないと、こういうことが同時にあるわけですね。2050年の時点で地球全体でカーボンニュートラルに持っていくと。こういうことをですね、今、パリ協定の中での努力目標から、これをフルにコミットしようと、こういう世界的な流れになっているわけです。そうした中で昨年、日本、菅総理がですね、2050年のカーボンニュートラルを日本として宣言いたしました。そして今年の4月にはですね、2030年という中間目標をですね、この2050年カーボンニュートラルに整合的な形で見直す。2013年度から 46% を削減し、さらに 50% の高みを目指すと。こういうですね、1.5 度のラインに沿った中期目標に変えたということであります。これは日本の国内の排出量の棒グラフでありますね。青い棒グラフの中に赤い最高値が2013年度。これは日本の場合はですね、2011年に東日本震災があり、原発の事故でですね、電気の供給構造が石炭化石燃料などになったことで一旦増えました。そこからの努力の結果、今6年連続で CO2 の削減を実現しております。しかし、今後ですね、2050年カーボンニュートラルに向けて、この削減の傾きをさらに2030年 46% ということでですね、削減を加速化していくということをですね、そして2050年に向かってやっていくということであります。11月13日にですね、COP26 が無事にですね、成果を上げて会合が終結いたしました。ここでは今申しましたパリ協定の文脈で2度目標ということからですね、1.5 度の努力目標を世界で共有しようと、こういう大きな流れの中での今回の会合でした。先進国、途上国、非常にそれぞれの事情がある中で、この 1.5 度目標に向かって努力を続けようということが明確になったサミットであります。特に日本からはですね、2030年までのこの10年が勝負であるということで、野心的な気候変動対策を各国に呼びかけました。そして特に途上国での対策対応のためにですね、資金的な援助が必要であります。最大100億ドルを5年間でやっていくという追加コミットメントをしてですね、世界の流れに大きく貢献をしたところであります。で、この今の現状、パリ協定の枠組みの中で2050年に向かって世界で削減をしていくというところを各国がそれぞれコミットメントをしていくということなんですけれども、現状のですね、目標、各国がコミットしているものの積み上げではこの 1.5 度にはならないと。このままの状況であるとですね、今世紀まで末に約 2.7 度ですね、の上昇に今の段階だとなってしまう。2030年段階でですね、15.9% と、こういうことなんで、これを削減していくということが、私たち世界の今直面している大きな課題なわけです。そうした中で、この中期目標の2030年断面ですね、EU はじめですね、その 1.5 度に適合する、50% とかですね、そのような削減の中で、中国は、2060年の段階でカーボンニュートラル、インドは2070年の段階で排出ゼロということで、ありまして、そういうことからも2030年の断面でですね、中国は2030年までは、排出量は減らない。そこから減るんだと。こういうことで、1.5 度の目標に沿った形に 世界全体をするためには、やっぱり大量排出しているところにですね、頑張ってもらわなければいけないと。こういうことになります。各国今回の COP26 に向けて、それぞれのできる限りのコミットメントは出ているということです。2050年排出ゼロに向かって、各国が、揃ってくる中で、今申しました、まだこれから経済が大きくなるような国においてですね、コミットが2060年とか、2070年とかいうことでありまして、南アフリカはですね、2050年のコミットということを表明しておりますけれども、そうした中での世界全体での野心の引き上げが求められます。次、キーテクノロジーとしての水素や触媒についての環境省の取り組みということでお話したいと思います。IEA ですね、国際エネルギー機関が出しましたネットゼロ by 2050というレポートの中でですね、今後2050年までにネットゼロにするためにはですね、気候変動対策として省エネ技術、再エネのシフト、需要側機器の電化、また水素および水素ベースの燃料、バイオエネルギー、CCUS といったものを取り組みが重要であるということを言っておりますけれども、特にこのレポートではですね、省エネ技術、再エネへのシフト、需要側機器の電化は全ての部門に削減に大きく貢献するであると。そして2050年までには全発電量の 90% 近くが再エネになると。そして排出削減が困難な部門、ここには水素および水素ベースの燃料、バイオエネルギー、CCUS といった新しい燃料や技術が大きな役割を果たすと。こういうことが内容として発表されております。日本におきましたこの水素、世界に先駆けて2011年に、日本政府といたしまして水素基本戦略をまとめております。この水素の技術を進んだ日本においてコストですよね。現在、ノルマルリューベ100円ぐらいの感じですね。これを将来的には20円まで持っていきたいと。それをやるために供給サイドの様々な対応、また需要の喚起ですね。サプライチェーン全体の対応、こういうものを、総力を上げようということであります。で、この水素の利活用分野ということになってくるわけですけども、この右側にありますように、今後ですね、トラックや船などの交通分野での利用ということが考えられますし、また火力発電自体ですね、水素発電に変えていくと、天然ガスを水素に変換していくということですね。そういうことの使用。そして、鉄鋼などですね、電化が難しい産業分野ですね。ここにおきまして、典型的には鉄鋼における水素還元でありますとかね。そういう分野での利用ということで、この大きくこの水素の活用というものは期待されるわけであります。そして、つい先般ですね、10月の閣議決定になりますけれども、2030年 46% というですね、1.5 度の2050年カーボンニュートラルに沿った中期目標のベースとなりますエネルギー基本計画の見直しにおきましても、2030年の段階で、1% 程度ということですけども、初めて、水素をですね、水素アンモニアで供給するということを明確にしたわけであります。具体的に水素をどのように展開していくかということですけれども、経済産業省と環境省が連携してですね、これからこの水素をコストが下がるようにですね、大きく利用を広げていくという対応を取ってまいります。経済産業省におきましてはですね、海外等も含んだ大規模な水素製造源を活用しつつですね、発電、鉄鋼などの産業における大規模な水素利活用というものを実施していくと いうことをですね、産業向けにグローバルなサプライチェーンも含めて考えると。再生エネルギーなどでですね、オーストラリアや中東で水素を作る。それをCO2 のかからない形で港に運んできて国内の産業に展開すると。こういうことが想定されます。また、環境省におきましてはですね、地域のですね、再生エネルギーを、その再生エネルギーを生かして、そこから水素を作っていくと。ですね、この地域における地域を自立分散、地産地消型のエネルギー経済システムに変えていくと。こういう構想の中で水素というものを国内の地域の再エネから水素を作り、地域で使っていくと。こういう大きなコンセプトのもとに政策を展開しておりますけれども、いずれにいたしましても経産省と環境省が連携してですね、この水素を具体的に国内に広げるということのフェーズに今入ったわけであります。環境省においてここに至るまでにもこの水素についてのトライをしてきております。水素サプライチェーン実証事業ということを展開しておりますけれども、全国10地域におきましてですね、この地域の再エネ資源を先ほど申しましたように水素に変えると、そして、地域のエネルギーとして利活用していくと、こういうメインのコンセプトのもとに、10の実証事業をこれまで展開してきているわけであります。環境省における水素サプライチェーン10カ所全国で今展開しております。そのうちの具体的な事例といたしまして、北海道鹿追町の事例がございます。これは家畜糞尿由来のバイオガスをですね排出して水素を製造し、燃料電池から得られる電気や熱を付加価値が高いチョウザメ養殖に活用し、キャビアの生産を行っているというものです。地域の資源を活用した地産地消型水素社会のモデルケースともいえるものであります。もう一つですね、福岡県北九州市ではですね、既存インフラであります廃棄物発電や再エネ施設の余剰電力、これを蓄電池で貯めると、そしてその再エネをですね、有効活用して水素を作るということ、そしてその電力市場とも連携しながら安い電力料金を活用してこの作った水素製造でですね、燃料電池やさらにフォークリフトということで活用していると、こういう事例であります。このように水素利用を進めていくためには触媒の活用が極めて重要であります。脱炭素技術で利用されている触媒の主な原材料としてはですね、資源制約の多いレアメタルやレアアース、プラチナ金属を活用しているものが多いわけであります。環境省ではですね、2020年度来年を想定しておりますけれども、こういうような状況の中で地域資源循環を通じました脱炭素化に向けた革新的触媒技術の開発実証事業と、こういうものを立ち上げようとしております。今申しました資源制約の多いレアメタルやレアアース、プラチナ金属の使用量を少なくした上で同等以上の性能を発揮する革新的な触媒の開発を行っていく予定です。革新的な触媒につきましては利用後には回収体制も構築してサーキュラーエコノミーにも合致した取り組みとしていきたいと思っております。最後のテーマですね、環境省として今後どういう社会を目指しているのかということについて最後申したいと思います。カーボンニュートラルをしていくと、地球が先ほど冒頭申しましたように気候変動、病気で病んでいるような状況ですね。これを健康体に持っていった健康体のイメージ、これをですね世界でSDGs が取り組んでおるわけですけれども、日本では地域循環共生圏、サーキュラー&エコロジカルエコノミーと、こういう概念でいわばローカル SDG というもので社会経済の仕組みを変えていきたいと。 3つの視点でこの最終形を見ていくと。エネルギーの断面ではカーボンニュートラルの脱炭素社会、そして、物のつながり方の断面ではですね、従来のような無限の資源を直線的に引っ張り出して大量生産、大量消費、大量廃棄して無限の吸収力がある地球に一方的に廃棄するというリニアの経済からですね、全ては有限で連携しているという構想の中で、サーキュラーエコノミーですね、全ては循環している、いわばもうゴミという概念ではなくて資源なんだということ、全ての資源として、あらゆるところでループが回っていくと、こういう経済のもののつながり方の視点、そして空間の配置という観点からですね、このコロナで大変明確になった一極集中の過度のリスク、これからですね、デジタルさまざまな技術も使って自然生態系に調和した形で自然と共生する形で分散の方向に行くと、この3つのベクトルがですね、調和した世界、これを私たちは経済社会の再設計の構想として地域循環共生圏と、地域の資源として水も食料もエネルギーも観光資源、健康アクティビティのもとも全てこの森里川海という言い方をしておりますけれども、自然生態系の恵み、これを技術を持ってうまく循環させていくと、都市と農村で補い合うと、こういう構想であるわけです。全てその循環していくという発想はですね、ベースには一つの企業やコミュニティ、学区、そういうような集落というところでの循環系から、その集合体としての市町村流域での循環、そのさらに上のレイヤーといたしましては東北全土とかですね、九州とか国内のブロック単位、そしてそのさらに上には環アジア、環太平洋で地球全体での循環と、こういう中で全てが循環し補い合い、エネルギーもですね、自然資源、食べ物、そういう発想の中で技術、人間の英知を活用していくと、こういう発想です。このようにまさしく勝負の10年というところで日本初でこのソリューションを見せるということですね。脱炭素、カーボンニュートラル、サーキュラーの循環経済、分散型自然共生社会、これをですね IoT、DX、さまざまな人間の英知技術を使い、その中には今日のテーマである水素、そしてその水素を人類が使うためには触媒の機能、レアメタル、レアアースをいかに賢く人類が無限ではない有限なものを使っていくかと、そしてそういう中ではあらゆるプレイヤーがパートナーシップを持つ、オープンイノベーションしていくと、こういう社会を日本初で今展開しているところであります。なんとかこの地球の危機的な状況からですね、この10年道筋をつけて未来の世代につなげたいと、こういう思いで制作をしております。本日はご清聴ありがとうございました。
Thank you, Mr. Nakai, for your wonderful presentation. As Japan is the leader and pioneer in so much hydrogen technology and adoption, what are the most important things as a government that you would like to share with other governments around the world to help us all reach net zero?
ありがとうございます。水素の技術をはじめですね、さまざまな技術英知を私たち持っています。特に日本はその宝庫だと思います。しかしそれだけでは、それはいわば木という全体の幹と枝という枝葉という関係から言うと、言ってみると枝葉のですね手段にあたる部分なんですね。この幹の部分の在り方が世界中で問われていると。この幹が壊れそうだというのがこの地球環境の今の状況です。そうした中でこの幹をしっかり軸を立てて、その幹が太る形のですねものを枝葉に活躍してもらって作ると、こういうことから考えますとですね、まさしく世界で共有すべきは先ほどお話しさせていただいたようなこの地球の健康体のイメージ、地球が一つの生命体であり生命システム、生態系システム、それが健康なイメージというのは やはり、ありとあらゆる生きとし生けるものがですね調和している、つながり合いながら循環と共生というですね、そのいわば生命システムを大きく健康であるかどうかのバロメーターになる軸ですね、こういう概念が世界に広まる、そういう意味で日本か地域からローカルから SDGs を具体化していく地域循環共生圏、こういう構想ですね。英語ではサーキュラー&エコロジカルエコノミー、今欧州を中心にサーキュラーエコノミーと言ってますけど、日本からはそこにさらにサーキュラー&エコロジカルと生態系の調和という概念を入れてですね、この軸を立てた幹を立てた中で、技術を活用していくと、その幹が太るような形で技術を使っていくと、こういうことをしていくことが大事だと思っております。
It is so important that we make the shift to net zero. So, how important is public engagement? Or does the lead in adoption come from government and industry?
この特にカーボンニュートラル気候変動の問題ですね、エネルギーと密接な分野ですので、エネルギー政策であるとか産業の供給サイド、特にイノベーション施策、そういうところでの政策っていうイメージにとかくなりがちではあります。それ自体は大変重要なんですけども、今や私たちの暮らし生存のベースである地球全体が健康体じゃなくて病気で壊れそうだと、こういうことから言いますとですね、むしろ暮らしや地域の視点でこのものをこのカーボンニュートラルの問題をもう一回見直すという段階です。特にその観点から言いますと CO2 の排出量、これは使われているという消費のベースでものを見ますと約6割が衣食住を中心とするライフスタイルに起因するという統計になっております。これはこのカーボンニュートラルやるにはもちろん衣食住を常にしている私たち暮らしの生活者の面もエネルギーを再生エネルギーに変えるということがあるわけですし、そして同時にサーキュラーエコノミーの発想でもう資源を有効に使ってもう家からゴミを出さないとかですね、資源として生ゴミを堆肥に変えてそこで野菜を作るとか、こういういろんないわば循環経済という文脈で取り組み、こういうものがソリューションになっていくと思います。そういう意味でこの企業も含めて一般の生活者の視点で企業の事業がビジネスモデルが変わる、そういうことにもなってまいりますし、一人一人が地球にこの危機に直面しているというその共有感、これが大事だというふうに考えております。
Thinking of the Japanese public, how ready are they to accept decarbonization, and how much of a sacrifice or compromise do you think the nation is prepared for?
世界的にいろんな人類がたどった歴史を見ましても、日本国民は非常に強靭でですね、対応力適応力のある国民だと思います。特に近代の局面では日本は明治維新という150年前の大きなレジーム転換というものを全く無血の革命ということで成し遂げた国でありますし、また不幸な第二次世界大戦というのがありましたけども、そこからの立ち上がり、戦後の大変革復興と、これは国民全体で乗り越える、そういうことができる国民である。また最近ではオイルショックの時のですね、大変厳しい経済の中で新たに産業を乗り切っていったということはありますけれども今回のカーボンニュートラルの文脈でもですね、日本人は非常に真面目であって几帳面であり、言ったからにはやらなければならないというもう非常に勤勉な国民性を持っています。したがって昨年10月菅総理がカーボンニュートラルを宣言すると、ここに至るまでかなり経済界や国民サイドですね、2050年カーボンニュートラルってなかなか言えないよねみたいなですね、本当に具体的に言ったからにはやらなければいけない、やる目処をどうするのかという、そういう議論がある中でコミットを なかなか踏み切れないんではないかというようなこともですね言われていたんですね。ところがもう世界全体の流れを見据えて日本として踏み出るんだということで昨年10月にカーボンニュートラル宣言をして言ったからにはやるんだということが今ひしひしと産業界経済界そして自治体各行政自治体ですね大きな流れになっておりましてこれはもう止まらないこれを我慢合戦ではなくていわば地球が傷んでいる状況これを健康体にするというのは地域が豊かになる私たちの経済や暮らしが豊かになるというそのことですからポジティブなものとしてこれに取り組むということが今の局面だと思います。
Given the great example of the Japanese state policy in advancing hydrogen technology and adoption, how are Japanese companies abroad replicating the success in countries where there is perhaps less government support for these initiatives?
はい、ありがとうございます。水素技術については日本が今世界のトップリーグだと思っておりますけれども、これを海外に展開して地球全体に貢献していく必要があるわけですね。でこれにつきましては日本におきましてはですね、政府も関わった形で、二国間クレジットというですね日本の企業などを持っている技術などを使って海外において CO2 が減るプロジェクトに日本がコミットすると。それで減った分をですね当然減った現地である途上国のカウントと同時にですね日本の貢献ということで日本としても日本国のカウントにも入れるとこういうことを二国間のお約束でやるシステムをすでに実績を積んできておりましてそれが今回COP26 の合意で市場メカニズムと大きく残された論点の決着もつきましてこれがどんどんこれから正式に世界で認知されて使えるという状況になります。ここのシステムですね二国間クレジットシステムを日本政府は力を入れておりまして政府の支援が少ないというお言葉もありますけれどもここは国内でまず削減する努力と同時にそこで使われるありとあらゆる水素もはじめですね日本の有益な技術を海外に世界に貢献する形で政府も関わった上で展開することは大いにこれから伸びていくと思っております。
How soon do you think the Japanese government operations will reach net zero?
はい、ありがとうございます。2050年カーボンニュートラルということを言いましたのでそこまでにやるということはもう確定なわけでこれを地球温暖化対策法という法律の基本理念に掲げて政府の体制が変わってもこれをやり抜くということにコミットしたわけですけども今やどうやってこれを達成するかということの手段が大事という中で地域の脱炭素のですねプログラムですねロードマップを作ったということなんですね。この2050年というのを待たず2030年までにできる地域は先にカーボンニュートラルになってくださいと、そういう先行地域を2030年までに100か所以上作りそしてそこからそのいろんなバージョンがあります。農山村地域、住宅地域、産業立地地域いろんなパターンの先行エリアを習う形でドミノでですね2050年に向かって突っ込んでいくこと、こういうことでそういう意味では全体としてのニュートラルは2050年ということにはなりますけどその手前でですね2030年までにここの地域はカーボンニュートラルだとこういうのが見えるというロードマップの展開をですねこれからやってまいりますので、そういう意味でそれをまた日本の、経験日本のロードマップの有効性をですね海外にも貢献してやっていきたいと、こういう考え方です。
Thank you very much for answering the questions, Mr. Nakai. And once again, Nakai さん、ありがとうございました。Next, we are delighted to introduce Dr. Katsuhiko Hirose, a renowned expert in hydrogen technology. Having completed his PhD in mechanical science from Kyushu University, Dr. Hirose joined Toyota Motor Corporation in 1981, where he played a central role in the development of the Prius and hybrid technology. He was then involved in fuel cell development, responsible for hydrogen energy and infrastructure, and played an important role in the development and commercialization of the Mirai, as well as Toyota's wider hydrogen vision. In 2015, he became a visiting professor at Kyushu University, where he is especially interested in not only the technical aspects, but also the societal role of renewable energy and hydrogen technology. Dr. Hirose will talk about the hydrogen markets and the global readiness for hydrogen adoption, as well as the breadth of applications for hydrogen across many sectors. Before the presentation, another quote for you. There is no better designer than nature. よろしくお願いします。
So good afternoon, good morning. So I'm talking from beautiful Japan autumn. So the background of my is you are supposed to see if you come to Japan. So please come next time. So it's a great honor to talk on this conference. This is second time. I talked 5 years ago about hydrogen. It's only 5 years ago, but the situation around hydrogen is completely different. So I have been an engineer in Toyota for 39 years. I'm still chasing hydrogen. So I'm lucky to be involved to big automotive technologies such as Prius hybrid and the Mirai fuel cell. So I'm still chasing hydrogen. So today I'm going to talk about the current potential of hydrogen and the future potential of the PGM and the hydrogen. So the future will be very simple because of all the energy are coming from the renewable and using optimal use of fossil fuel. So this is a picture I wrote 10 years ago. That time, the people said this is too extreme because of the renewable cannot be a main source of the energy. But now everybody talking about the renewable is the main source of the future energy. But the world is propelled by the energy, but electron cannot propel whole the world. So we need hydrogen. Even the electrification will be increased, but still we need a lot of molecular like hydrogen or chemical. So 4 years ago, I was involved to establish the Hydrogen Council. It started only 13 companies. But lucky to have a whole the executives, including my former boss, Mr. Uchiyama, the chairman of Toyota, and also the founder president of the Shell and many guys. Where I wrote a report about hydrogen future. Oh, by the way, the Hydrogen Council now more than 100 companies. So the report said hydrogen can help mitigate the current climate change. So previously the hydrogen was supposed to be a fuel for the future car, but the recognition of the hydrogen will be completely changed. because of the hydrogen will help to increase the number of the amount of the renewables, and also the help to trade to renewable, and also decarbonize the transportation and industrial energy, and also the heat, and even the feedstock of the chemical industries. And previously, the climate change is a big expense for the world to tackle with. But the interesting report of this Hydrogen Council report is it will create $2.5 trillion of the business and also 30 million jobs. This changed everything because of the people first time recognized working against climate change is no longer just expense for the environment. It is investment for new business and job. So when I talked last time in this conference, no country committed for hydrogen. Then the Japan 2017 made the hydrogen strategies. Then, like this picture, the many countries followed. Even the Saudi Arabia, the king of kingdom of the fossil fuel, are now building hydrogen strategies. And this is a map of the world where the countries or region committed for the hydrogen strategy. Then after the COVID-19, situation has been changed again because of the people seeking to for the plan for the COVID-19. This is another report because we analyze the amount of the hydrogen to be produced to reduce the cost competitive with fossil fuel. It said we need $100 billion to investment, but at that moment, $100 billion is huge money. So it takes 15 to 20 years to gain such an investment. But after the COVID-19, $100 billion is very small against the current after COVID-19 recovery plan. So Build Back Better catches hydrogen. One of the reports said, if you invest or if you build a 65 gigawatt of electrolyzer, hydrogen can be cheaper than fossil fuel. Then the EU strategy came out with a 40 gigawatt plus 40 gigawatts outside EU strategy. That's actually aiming to reach such 65 gigawatt facility. So this is also the target of the European countries. All the countries set the electrolyzers target for 5 gigawatt for Germany, 65 gigawatt for France, and other countries follows. And also very interesting is they also set the investment target, like a 9 billion euro for Germany and 7.2 billion euro for France. This is completely different from the previous hydrogen strategy, such as Japan. So Japan sets cost target to compete fossil fuel. But this time, the European strategy is setting the no cost target. They just promise to invest a huge money and to build huge amount of the electrolyzer to reach the cost down to compete the fossil fuel. So showing that their strong will for the climate change. Then this is also the latest report from Hydrogen Council. In July 2021, the 360 projects are ongoing, and estimated value of the investment is $500 billion. And also the electrolyzer already exceeding 65 gigawatt. So actually the attempt from the EU is going to be success. And hydrogen for transport is also 5 years ago, the people talking about the hydrogen for fuel for the cars. But now, so all the transport from aviation, the marine, and the train are all going to be their own emissions with hydrogen. Very frequent, the skeptics about hydrogen is when you have a renewable energy, you convert into the electricity, then back to electricity, you use a huge amount. If you are using a battery, you have a much more energy left. But I'm talking a little bit differently. This is a picture I took in Lausanne in Switzerland. There are more cheese shops than the meat or bread. I recognize that you eat bread and the meat every day, but the more the cheese shop means for business, selling a cheese makes more profit. So this is a normal comparison of the battery system on the left and hydrogen on the right. So you store the energy. Battery gives better efficiency when you take the electricity out. But I recognize the hydrogen can be some kind of cheese. So in summer, you have a lot of milk, but milk cannot be stored. So from the energy point of view, drinking milk is better than after changing into the cheese. You lose huge energy. But from the economic value, the cheese has own value. So create a product value like a cheese and also time shift value because you can eat the winter. And also the another value is replacement value because of the cheese can, once cheese are formed, cheese can compete expensive appetizer like a salami or caviar. So the pricing can be done by the those replacement value. So the electron is getting cheaper and cheaper. That means this is like a mu. So if you convert the cheap electron into chemical like a hydrogen, you have a time shift value and the replacement value. But when you store the electron in the battery, you can only get electrons. So this is the economic value of the electron hydrogen conversion. So from thermal point of view, you will lose some energy, but from the economic value, this conversion makes more values. So I always said that the hydrogen conversion is not the energy conversion, it's a milk cheese conversion. This is a little bit academic picture. So when you convert from electron to the hydrogen, you will lose some physical value like a thermal value, but you gain a little bit more chemical, the market value as a chemicals. And if it is used in a fuel cell, that because of the fuel cell, the efficiency can be 2 or 2.5 times better than the combustion engine. So that means you gain a lot more kilometer from the same kilojoule. So this is also gaining a market value. Then in this stage, the hydrogen can compete oil, but still difficult to natural gas or coal. But things is ongoing differently because of the carbon or carbon dioxide is no longer allowed to emit. So you have a disincentive or penalty. And so that is the discussion in $50 for France to $130 in Sweden. But it will go into increase definitely. So in this carbon tax, the societal value of hydrogen can be much more than just physical value of the thermal value. This is the interpretation of that milk cheese conversion. Another aspect of the hydrogen is that many people think the future will be electricity, but electricity has a very complex, fragile system. So within a millisecond, the generation and consumption need to be balanced. Otherwise, you have a blackout or this. But if you convert into the hydrogen pipeline can store the hydrogen by pressure. So if you have an extra renewable, you can just produce hydrogen and compress into the pipeline. You can build up the pressure, but quality of the energy is same. And at the same time, this pipeline can store a huge amount of energy. Like 1,000 kilometers of the hydrogen can store 70 gigawatt hour of electricity. So as a basic backbone of the future, you need a very robust, non-fragile backbone system. So hydrogen pipeline can be a very robust backbone. So if you use a lot of hydrogen, the pressure can be down, but still the 1 kilogram of hydrogen produce 120 megajoule of the energy. So while the electricity you use too much, the voltage down, and then the quality of the energy is going down. For example, I'm raising some of the interesting plan for Japan. We have a huge renewable in Hokkaido. So if you can produce a lot of hydrogen in Hokkaido and transmit to Tokyo, you can produce huge amount of domestic energy, and you can still store a huge amount of the energy in the pipeline. So I said that the future, the societal backbone of the energy can be hydrogen, of course together with electricity. At the same time, the role of a PGM can be different in the future. Currently, the PGM is the very big role is to clean up the polluted exhaust. But the future, a lot of electrons need to be converted into the hydrogen or chemical or many things. So you need a PGM to convert efficiently. And also for the use, from hydrogen, you need to convert into the function like heating or propulsion or even produce a chemical. In this conversion, you need a PGM. So the PGM role is changed in the future from the very passive role of just cleaning up the exhaust to the proactive role to convert the energy into the preferable status and efficiently. So all the problem of the north to south or rich and poor are related to the energy. So hydrogen can cut these kind of the because of the renewable can be more diverse producible. So each country in the world can choose their own way to feed your car, feed your house, and heat up your house. You no longer need to import a very expensive oil. So I like this word very much. End of Stone Age was not due to the lack of stones. The technical innovation and new idea changed the society. So, and also we cannot change the past. It is very difficult to modify the present. However, we can change our future. We can even design our future. And it's fun and beneficial too. So carbon neutral means we can design our future with a $1 trillion budget, because normally we are spending trillion for Japan. We are using $200 billion every year to import energy. For Europe, we are spending $400 billion every year to import oil and fossil fuel. If you multiply for another 20 years, 30 years, it becomes the tens of $trillion. So the carbon neutral means we can use these kind of $1 trillion of the budget, design our future. So I said energy transition makes you for young, that challenge and jobs for young generation, and investment destination and return for all the generation. And also we can share the happier dream for all. So energy transition is not a very difficult challenge. Of course, it's not easy, but we can enjoy because we can create our own future by ourselves. Thank you very much.
Thank you very much, Dr. Hirose, for a most informative presentation. I think the analogies that you use with milk and cheese just make it so easy for us to understand this really complicated chemistry. Which age group or demographic group do you find in society today is the most engaged with the opportunities for hydrogen adoption?
It's a difficult question and an easy question because of everybody can get a benefit. So because of the renewable energy can be very universal. So you can get anywhere in the world. So in the northern part, you have a lot of wind, not so much solar in winter. But so I said that new energy transition will give a hope for the very young people who are a little bit frustrated for the last few decades or so, and also the older people trying to find a place to invest because they need money for their pension. So I think that the hydrogen or energy transition will give the both generation a big benefit and hope.
How do you think we can educate the political leaders of the world to understand and take seriously the need for greater adoption in hydrogen?
I think I tried a lot in the past, but very difficult from the academic figure like that we can save several gigaton of the carbon dioxide. It cannot penetrate for those people. But when I talk, the potential of hydrogen creates the $2.5 trillion of business and 30 million jobs. So hydrogen is a vector to make the society more flexible and robust. This kind of the message we need to repeatedly talk to the politicians.
Is there any particular industry or sector that is ready for hydrogen adoption? And in that sector, how long will it take and will it cost a lot of money?
Very difficult to predict because of the solar panel. When you ask the same question 20 years ago, people said, "Oh, very difficult. It takes the half century or so." But now the solar panels dominate the world. So it will be a competition between the sectors, the industries, to catch the benefit of the energy transition. Definitely those sectors which are difficult to decarbonize with electricity can be accelerated within the next few years, like steel making or chemical industry. Previously, it was supposed to be very difficult to decarbonize.
Are there any other important projects that need to be visible and successful in the medium term to ensure hydrogen adoption?
Interesting, of course, so the very visible projects ongoing in northern Germany and Netherlands to convert from the natural gas into the windmill hydrogen projects are very, very visible, interesting. But at the same time, in the like a Gulf country like Saudi Arabia or UAE are moving also quite rapidly, and also the Australia or these. So interesting to compete each other. Who can be the first to implement hydrogen? That is a very interesting competition, yes.
Dr. Hirose, your presentation brought to mind questions about scaling up. Can you just talk a little bit about the scale of hydrogen operations? Small scale, large scale, compared to existing technologies. What do you see as the pros and cons of electrolysis and fuel cell technology? How is it going to be scaled up? At the moment, it's very small, but how is this going to increase and penetrate society as you put it in your presentation today?
That's incredibly rapid growth is expected. So currently the world's largest electrolyzer is 10 megawatt in Japan, in the Miyagi, and also the 10 megawatt in, I think, the Berlin, near Berlin, North Germany. But within a few years' time, it's going to increase to 4 gigawatt or 5 gigawatt in Germany. That means 100 times more within a few years' time. So scaling up is very rapid. At the same time, for scaling up, you don't need a very new exotic technology, because of the current electrolyzer can be scaled up, and both PEM electrolyzer and alkaline electrolyzer can be scalable up to those kind of the big one.
And how big is the challenge, or is it going to be very simple to see the scale up of hydrogen technology and adoption in the developing world, in Africa, and some of the Asia-Pacific region, India, and China? Is this going to be a very, very high wall to climb?
I think that only a year ago, investment was the biggest obstacle, because of the most of the investment needs return within a 5 or 10 years time, because hydrogen or this kind of the investment need 20 or 30 years for return. But current movement about the divestment from the fossil fuel to the renewable, and also the company who announce those kind of the developments are gaining a huge amount of money. So biggest obstacle is how you show the good projects on those Africa or Southeast Asia. That is the biggest obstacle. But like I said, if you're in Africa, instead of spending billions of money to import oil, it is better to build the self-sustainable energy system, and all the gain can be reinvested. That will, I think, increase a huge, accelerate the growth of those countries. So together with investment for those growing countries, the money can be returned very drastically. So energy transition investments trigger the real economic growth of those countries. So you need to show those kind of big picture, but once those picture catches money, that can be possible. It's not easy, of course, but the good idea now can attract a lot of money and makes it possible.
For many investors, fuel cells in the hydrogen space has been something that was 10 years down the road. And every 10 years, it was still another 10 years down the road. Could you please tell me the timeline? When do you think we will get really good traction towards hydrogen? And when will we see the use and rollout of electrolyzers and fuel cells in the auto sector and other applications?
Yeah, that is same for the electric vehicles. So electric vehicles in California are discussed in the 1970s because of those mosquito. They could kill the combustion engine, and the people talking about electric vehicle. So electric vehicle had 3 waves: 1970s, 90s, and the 2020s. So, but now finally gaining a real. The fuel cell is same. The first wave is 70s or 80s, and the second wave is early 20s. But now the Hyundai and Toyota are going to produce hundreds of thousands of fuel cells, and also the announcement of the heavy-duty fuel cell cars are everywhere. So I think it's finally getting the real economy. And same for the electrolyzer, yeah.
Dr. Hirose, thank you very much for your time and your wonderful presentation. It was very interesting hearing you talk. I'm extremely grateful for your answers and presentation. Thank you.
Thank you very much. You're welcome.
Now, to warmly welcome our next expert speaker, Dr. Graham Cooley, Chief Executive Officer of ITM Power. As Business Development Manager at National Power plc, Dr. Cooley spent 11 years in the UK power industry, developing energy storage and generation technologies before joining ITM Power as CEO in 2009. ITM Power is committed to providing hydrogen solutions to alleviate the world's dependence on fossil fuels. The company has globally recognized expertise in hydrogen technologies designing and manufacturing hydrogen energy systems for energy storage and clean fuel production. ITM Power entered into a strategic partnership with Sumitomo Corporation in 2018, and in 2021 announced it was deploying its first electrolyzer in Japan along with Tokyo Gas. Dr. Cooley's presentation today will discuss green hydrogen and economics, specifically addressing the economics of PEM technology and how and when green hydrogen can become competitive. Before the presentation, another quote for you. It is this alone of all elements around us that has never found an enemy of man. よろしくお願いします。
So hello everyone, my name's Graham Cooley and I'm delighted to be joining this meeting to do with green metals and hydrogen. Just to begin with a quick piece of positioning about ITM Power. ITM Power is an electrolyzer manufacturer. We're based in Sheffield in the UK and we manufacture PEM electrolysis equipment. PEM electrolyzers are those electrolyzers that you can couple directly to renewable power and you make green hydrogen at high pressure. And this year, ITM Power moved into the world's largest electrolyzer factory with a capacity of 1 gigawatt per annum. We are now expanding our manufacturing capacity and we have a plan between this year and 2024 to increase our annual capacity, manufacturing capacity, to 5 gigawatts per annum in response to huge demand for PEM electrolysis equipment worldwide. I'm going to talk to you about what that demand looks like and the markets and the development of PEM electrolysis, particularly going to talk to you about scaling. ITM Power also announced a few weeks ago that we had raised 250 million on the capital markets, and today we have resources of 400 million. So the macro picture then, first of all, I was delighted to see the publication of the IEA report. It was published in May of this year, and it identifies that the world needs 3,500 gigawatts of electrolysis to get to net zero by 2050. This is a very large number. Actually, we're in the world's largest electrolyzer factory, and this number is 35 centuries of the production of our factory to be delivered in just 29 years. And if you work out the total amount of capital equipment, that constitutes over $2 trillion of capital equipment. So a massive market. The Aurora Energy report, also published in May of this year, identifies 200 gigawatts of electrolysis projects already under development, 85% of them actually in Europe. And if you add up all of the national targets for electrolysis equipment, that is the targets that have been announced from nations developing a green hydrogen strategy, they add up to just under 150 gigawatts. And I think a very significant announcement on the 7th of June from the DOE in the US was the Earthshot. To get the US to net zero, the first Earthshot that was announced was the green hydrogen Earthshot to reduce the cost of green hydrogen to $1 a kilogram within the next decade. And in fact, the Biden administration's infrastructure plan was announced yesterday with $10 billion for low carbon technologies, including hydrogen. So we see very, very strong policy and market momentum. In terms of that momentum reflected in ITM Power's numbers, today we have a record backlog of 310 megawatts. And we have tendered over the last 12 months, we have tendered. So this is where we have submitted a quotation for capital equipment against an international competitive tender. And we have submitted 1,011 megawatts of quotations in just 1 year. And you can see the progress of our backlog in the first graph on the left-hand side. And on the right-hand side, you can see that graph rescaling. The top of that scale then is 1.2 gigawatts. And the blue line shows you how rapidly those quotations against commercial tenders are increasing. In fact, that curve is going almost vertical. This is genuine exponential growth in the market. And we put this number out periodically, this tender pipeline number, because the capital markets wanted to have a tangible measure of market progress, rather than just looking at a whole series of press releases about letters of intent or MOUs. So these are real tenders in the market. What is our offering then to the market? So at ITM Power, we manufacture 2 and 5 megawatt modules. So we have 2 core products, a 2 megawatt module and a 5 megawatt module. And those are integrated by our partner, Linde Engineering, into full systems. And in the diagram on the right-hand side, you can see a full system. Actually, in this case, the image is of a 100 megawatt plant in Humberside in the UK. This plant is connecting directly to Hornsey 2, which is a 1.4 gigawatt offshore wind farm owned by Ørsted. And that 100 megawatt electrolyzer is going to connect directly to one of the 300 megawatt bays and make RED 2 compliant hydrogen. That's the Renewable Energy Directive's specification of green hydrogen. And the hydrogen will go directly into the Phillips 66 refinery, which is next door. And this FEED study with Linde Engineering includes pre-engineering 20 megawatt packages. So not only are we standardizing at the level of the module, we're also standardizing at the level of balance of plant to drive out costs. We delivered this year as well 10 megawatt electrolyzer to the Rhineland refinery. And this is Shell's refinery, which has been rebranded the Shell Energy and Chemicals Park in the Rhineland. And we were delighted to get the news that we have now funded with Shell a 100 megawatt plant. And this green hydrogen plant that is going to be built by ITM and Linde Engineering will be producing synthetic kerosene, sustainable aviation fuel. And this now is the world's largest electrolyzer, and it's deployed directly at a refinery. So an incredibly important reference plant for ITM. And it's worth pointing out that ITM has been working in collaboration with Linde and Shell now on PEM electrolysis equipment for more than half a decade. So a very important announcement for ITM. We not only deploy electrolyzers, but of course we monitor them in the field. We provide all of our customers with an after-sales support package. We gather data. We work using that data with our customers to optimize the performance of the plant. And we also use that data for continuous improvement and designing the next generations of electrolysis equipment. So very important to get the real learnings from the field. ITM Power has been building and deploying electrolysis equipment now for 20 years. So we have a lot of experience, not only in the technology and scaling the manufacturing, but also in operating the electrolysis equipment in the field. Our manufacturing now is accelerating rapidly. We've developed a digital twin of the factory. We have an automation partner, and we are building a second gigafactory in the UK of a larger capacity, actually a capacity of 1.5 gigawatts per annum. This was announced at the beginning of this week. And that plant then will have additional automation. And this is all about driving out costs and increasing the speed of manufacture and reducing lead times. So again, a very important development for ITM. So if I could just summarize then, our progress over the last year has been very strong. We moved into the world's largest electrolyzer factory. We achieved a record backlog of 310 megawatts and achieved a record tender pipeline of over a gigawatt. We've experienced incredibly strong market and policy momentum, and we did all of this in the middle of a pandemic. So a very important year for ITM, and the outlook, I think, for the coming year is very, very positive. So I look forward to being able to make further announcements, and I hope that all of the audience will be interested in tracking ITM's progress going forwards. So thank you very much to everybody for listening.
Thank you very much, Dr. Cooley, for an outstanding presentation, and very informative it was too. The transparency and detail in your slides are eye-opening, and it's wonderful to see the progress of ITM Power and the direction the world is taking to address climate change. I know that you've been very busy in Japan, but which other regions are the most promising for the adoption of PEM electrolyzers and why?
First thing to say about the Japanese market is that we have a very valued partnership with Sumitomo Corporation. We've been working very closely with Sumitomo now for about 6 years. And we work with them not only in introducing our products into Japan, but also we work closely with them in Australia. And we made an announcement of our first electrolyzer reference plant, a project in Japan working with Sumitomo Corporation and Tokyo Gas. So this first project is our first reference plant in Japan, where we're producing a PEM electrolyzer that is compliant with the Japanese gas laws. And as you probably know, the Japanese gas laws for hydrogen mean that you would operate the electrolysis equipment at a lower pressure, which meant some design changes for ITM Power. But now what we have, working with Sumitomo and Tokyo Gas, is a compliant product for Japan. So we are taking the market in Japan very seriously. I think that hydrogen is an important molecule for Japan. And the Japanese industry has really been a thought leader in the area of hydrogen. Not only hydrogen for fuel cell electric vehicles, but also looking at importing green hydrogen and green derived molecules into Japan. And one of the key things about our work with Sumitomo is looking at how you might generate green hydrogen in territories like Australia and importing that hydrogen into Japan. And we also worked with Mitsui Bank and Chiyoda, looking at doing a similar thing from the hydro in British Columbia. So I think that, when you look at Japan and you look at the thought leadership that there has been in the area of hydrogen, it's incredibly impressive.
Perhaps you can give us an idea of what developing regions will need and how they will step up to participate in the production of green hydrogen.
Yeah. So one of the key propositions of green hydrogen is your ability to store renewable power. I mean, effectively what you do when you use green hydrogen is you turn electrons into molecules. And the reason that that's important is that electrons are incredibly difficult to store. Actually, if you split water using an electrolyzer and turn the electrons into molecules, they are storable and they're also transportable. So what this means is that not only can you capture the energy from renewable power in times when it's not needed on the electricity grid, and not only do you provide renewable energy companies with a new product so that they can now make molecules as well as electrons, but you also make renewable power transportable. So it gives you the possibility of transporting renewable energy from places like Australia and Canada that are rich in renewable energy resources, all the way to countries like Korea or Japan, where there is a need to import renewable energy. So it's this storing of electrons and making renewable energy transportable. What you then end up with is an internationally tradable green hydrogen commodity. And the key device to achieve this is the electrolyzer. And actually, the key reason that we're here today talking about electrolysis is that electrolyzers use platinum group metals as catalysts to produce the hydrogen and the oxygen. So where would you do green hydrogen projects? Well, there's a very simple answer to your question. What regions are important? Anywhere where you have an abundance of high load factor, low cost renewable power, that's where you would make green hydrogen. And anywhere that wants to decarbonize its energy but doesn't have high levels of renewable resource, that's where you would send that energy to. So there are net producers and net consumers.
Thank you. That was very helpful indeed. In Japan, over many decades, there's been a great affinity to platinum, particularly in jewelry. It's one of the biggest jewelry markets in the world. The key metals involved in electrolysis include not just platinum, but also iridium and ruthenium. So, could you explain the special properties of these metals and why are they so important?
So ITM Power has been working on PEM electrolysis now for 20 years. And we've been working for 20 years on the way that you use platinum group metals and precious metal catalysts to produce hydrogen and oxygen using PEM electrolysis. We work on the formulation of inks. We work on coating membranes and electrodes so that you have not only the best performance in terms of efficiency and voltage, but also current density. And actually, current density and performance combined together gives you the lowest levelized cost of hydrogen production. And you need both. So we worked on a very significant program of electrochemistry to understand how you use these catalyst systems. And to directly answer your question, what are the properties of these materials that make them so important for electrolysis? It's the fact that they split water at a low voltage, but also at a very high current density. It's the fact that you can manipulate these catalysts to disperse them in particles, which means that you can produce a very, very high surface area, minimize the amount of materials that you're using so that you can reduce costs. And we've spent many years formulating catalysts, also applying those catalysts. So we make our own systems, we coat our own membranes, we coat our own electrodes, we make everything inside the electrolysis equipment. And the reason we do this, the reason we're interested in vertical integration is that it's very important to manipulate the materials so that you can influence all of the factors. Customers buy on the basis of cost, performance, and lifetime. And in any technology, there's a complex relationship between these three things. And it's all about optimizing the systems to get the very best cost, performance, and lifetime all in one go.
I think one of the greatest successes we've seen with ITM Power has been its global reach, and in Japan, it appears that this has been achieved through strategic joint ventures. In your comment, you refer to vertical integration as being key to the future adoption in terms of efficiency and costs. How about recycling? How long do electrolyzers last? What parts of an electrolyzer need to be replaced, and how often?
So the lifetime of an electrolyzer, having an electrolyzer which is closed loop, so this is having a way of recycling all of the components, looking at end of life value, and also working that carbon footprint through so that you can look at the amount of embedded carbon in the product that you make is incredibly important. I would say, as a general principle, any manufacturer of capital equipment that is directed towards the energy transition needs to be able to articulate the amount of embedded carbon in the production of its product, and also show a closed loop where all of the components used have end of life value and are recycled. And we spend a lot of time at ITM thinking about reuse, recycling, and reducing the impact of materials in our products. And all of those things are very, very important, not only for ITM, but also for the planet.
Given your outline on adoption, production, and recycling, where do you think the greatest scope is for improving the economics of PEM electrolysis?
I think, first of all, in terms of the modules themselves, this is the stacks and the way that the stacks are packaged. The increasing current density is important. The biggest value that you get from an electrolyzer, if I talk about cost, performance, and lifetime, the most important thing is to have a high-performance electrolyzer, because the cost of green hydrogen is dominated by the performance of the electrolyzer, not its initial cost. And the reason for that is that the cost of green hydrogen is dominated by the cost of the energy, i.e. the renewable power that you told through. Increasing the current density and keeping the same efficiency is very, very important. Also, reducing the cost of the balance of plant. Because an electrolyzer is not only the module, it is also a power system, a control system, a water system, and a gas system altogether. I think also the electrolyzer industry, there's a very, very important synergy. And the synergy is with the water industry. You know, if you transition to renewable power and green hydrogen as your net zero electron and your net zero molecule, that industry, even though it uses the electrolysis of water, uses less water than conventional generation and conventional fuels. It also makes oxygen, and oxygen can be used in water treatment. And so I think that one of the ways that we can reduce the cost of green hydrogen is more carefully look at the synergies with the water industry and the desalination industry and the utilization of oxygen.
These questions are on the minds of many people around the world. What would you say as parting words on the adoption of PEM electrolyzers?
I would say this, I'd say that the only viable, huge volume, long duration energy storage medium is green hydrogen. Green hydrogen is also the only zero carbon fuel. It's nature's zero carbon fuel. And adoption of green hydrogen is essential to getting to net zero.
Thank you very much for answering all my questions.
Thank you for having me.
We are honored to be joined next by Mr. Takahito Furuya, the president of Furuya Metals. Under his corporate philosophy of contributing to the development of scientific technology and the prosperity of society, Furuya Metals promptly deals with issues concerning environmental and energy conservation as it pursues its research into the development of green metals and their industrial applications. Mr. Furuya will provide us with a fascinating insight into how to optimize the consumption of the green metals, iridium, ruthenium, and platinum. He will also discuss using nanoalloy technology to support green hydrogen development and describe how Furuya Metals' refining capacity can support the supply cycle. And again, a quote for you. Miracles do not, in fact, break the laws of nature. 古谷さん、よろしくお願いします。
この度はグリーンメタルと水素国際カンファレンスでお話をさせていただく機会をいただきまして誠にありがとうございます。本日は脱炭素化に貢献するフリア金属の技術というテーマでお話しさせていただきます。まずはじめフリア金属のご紹介をさせていただいた後に脱炭素で重要な水素製造に不可欠なグリーンメタルに関連するナノ合金技術と貴金属回収生成技術の2点をご説明させていただきます。フリア金属は PGM の用途開発、製品加工および回収生成をしております。PGM はプラチナグループメタルの略称でプラチナ、イリジウム、ルテニウム、パラジウム、 ロジウム、オスニウムの元素群を指しております。PGM は高強度、高耐熱性、耐薬品性などの優れた特性からさまざまな工業分野で活用されており、我々は PGM の中でも特に優れた特性を持つイリジウム、ルテニウムに着目し、長年にわたり技術開発を進めてきた会社です。イリジウム、ルテニウムで世界一をスローガンに挙げ、ビジネス展開をしております。次に我々のビジネスモデルのご説明をさせていただきます。PGM は金属元素の中で優れた特性を有する一方で、とても希少性の高い金属でもあります。PGM の年間採出量は約500トンですが、希少性の高いことで知られる金の採出量の10分の1程度です。よって工業分野で安定的に使用していくためにはリサイクルが不可欠であり、当社は効率的な回収、生成、高純度化技術開発に積極的に取り組んでまいりました。製品製造から使用済み製品のリサイクルまでを一貫して行い、お客様に高品質な製品を提供するとともに、安定的に資源循環させるサーキュラーエコノミー社のビジネスモデルでございます。このスライドは我々のビジネス領域と主力製品についてご説明させていただきます。我々の製品はありとあらゆる工業分野でご活用いただいておりますが、でも特に電子材料、半導体、記録媒体、化学、貴金属リサイクル分野において必要不可欠な資源として重要性度がますます増しております。まずはじめに紹介させていただくのはイリジウム合金を使った製品でございます。イリジウムは加工、リサイクルが非常に難しいメタルですが、この開発にいち早く着手し、長年技術を磨いてまいりました。イリジウムるつぼは融点2000度 C を超える材料を溶かすことができる超耐熱容器であり、通信デバイスで使用されるセラミックス部品の製造に使用されております。また、超高純度イリジウム化合物は有機 EL の発酵材料の原料として使用されております。いずれも高いシェアをいただいております。当社のイリジウム製品はスマートフォンに代表される通信機器を製造するのになくてはならない技術となっております。次にルテニウムを使った製品です。ルテニウムはイリジウム以上に加工が難しいメタルでございますが、こちらも当社の独自技術で高精度の加工に成功しております。ルテニウムターゲットはナノ薄膜を作る原料であり、また ハードディスクドライブに搭載され、世界中のデータセンターで使用されております。また、ルテニウムの特性、性能が半導体の省電力化に貢献することから次世代半導体分野でも注目されております。もうすでに一部のプロセスで使用が開始されており、この分野での用途拡大が有望視されております。温度センサーについて、当社はセンサー素子のプラチナ合金素線から部品の赤本管まで一貫生産できる世界でも数少ない体制を構築していることが特徴です。主に半導体製造装置における高精度な温度制御が求められるという分野で使用されております。製品紹介の最後は、本日のメイントピックスである水電解と関連する電解工業電極向けのイリジウム、ルテニウム化合物製品です。当社の化合物に含有されているイリジウム、ルテニウムが高純度であることを特徴としておりますが、主力原料である塩化イリジウム、塩化ルテニウムの生産キャパシティでも世界最高レベルであり、非常に高いシェアをいただいております。続きまして、脱炭素で重要なグリーン水素製造に貢献する当社の技術を紹介をさせていただきます。PGM は自動車排ガス浄化触媒と化学燃料をベースとした産業分野を中心に使用されてきましたが、今後の用途は脱炭素の流れの中で水素、アンモニアなどのクリーン燃料を中心とした産業向けに活躍の場がシフトしていくものと考えております。水素製造にはグレー、ブルー、グリーンとさまざまな製造方法がありますが、本日はグリーン水素製造に関連する当社の技術を紹介をさせていただきます。はじめに我々の開発対象についてご説明させていただきます。グリーン水素を製造する方法はいくつかありますが、当社では実用化フェーズの技術であり、また再生可能エネルギー利用と相性の良い PEM 水電解用の触媒材料を開発しております。特にアノード電極では高い性能と耐久性が要求されております。現在はイリジウム系の触媒が使用されておりますが、当社でも触媒のさらなる高性能化、高耐久化を目指した触媒開発を行っております。グリーンメタルは非常に良い性能を有しておりますが、資源量が比較的少ない金属です。この金属を安定的、持続的に使用していくためには、少ない量で十分な効果を出す効率的な利用技術が必要になります。例えば、水電解反応で有用とされているイリジウムとルテニウムは2つ合わせて年間約30トンの産出量ですが、性能を10倍に上げ、 10分の1の使用量で効果を出すことができれば、実質的には300トンの資源量があるのと同じと考えております。これを実現し、安定的にグリーンメタルを供給していくための技術として、ナノ合金技術と回収・生成技術の開発に力を注いでおります。我々が注力しているのは、触媒の性能を10倍にし、10分の1の使用量で効果を出すための基盤技術であるナノ合金技術です。本来金属は水と油のように混ざりにくい組み合わせが多く、特に貴金属の合金化は難しいです。京都大学の北川博教授が金属元素を自由自在に合金化させる革新的な技術を開発しました。この技術を用いることにで、従来は製作不可能と考えられていた新規合金が創出されており、今回テーマの水電解水素製造を含めて、従来触媒を大幅に量化する性能が確認されております。北川教授は当社の技術顧問でもあり、さまざまなご指導をいただきながら技術開発を進めております。当社は北川教授が開発したナノ合金の量産製造技術開発を実施しており、製造量も年々スケールアップしております。合金化とナノ化の相乗効果により、触媒の性能耐久性向上と希少なメタルの含有量低減による安定利用を実現するというコンセプトで製品化を目指しております。実際に量産製造装置の導入ももうすでに開発しており、これらの社会実装に向けて着実に準備を進めております。ここから当社で開発を進めている水電解触媒をご紹介申し上げます。こちらはイリジウムとルテニウムを合金化させた材料で、従来のイリジウム触媒の5倍の性能を実現しております。また、単金属のイリジウムは7トンの産出量でありますが、24トンの産出量のルテニウムと組み合わせることで、資源制約を緩和させる効果も生み出しております。次のスライドは、イリジウムとフトロンチウムを合金化させた材料です。こちらも先ほどの材料と同じく、イリジウムを上回る性能を発揮しております。性能はイリジウム、リテニウム合金より劣りますが、フトロンチウムは PGM と比較すると資源量が豊富であり、資源制約の解消という観点では大きなメリットがあると言えます。今ご紹介した2つの材料は優れた性能を有しておりますが、の方々が資源の心配をすることなく、グリーンメタルを活用して続けるためには、さらに高性能で資源制約の少ない材料を開発していくことが必要だと考えております。そのために我々は 北川教授のご指導のもと、さらなる高性能化、高耐久化、省資源化を目指し、多元合金の材料開発、量産製造に着手しております。産出量が限定されている PGM、その中でも特に資源量の少ないグリーンメタルの安定利用を支える回収生成技術についてご説明申し上げます。我々は長年にわたり培ってきた回収生成の技術や経験をベースとしてさらなる技術革新にチャレンジしております。先にご説明申し上げました PGM の合金化もその一つでございますが、資源の有効活用という観点から PGM 利用の省資源化が進んでおり、低濃度 PGM 概入スクラップからの効率的に PGM を抽出生成する技術開発の必要性が近年高まっております。ここで非常に重要なのは、低濃度スクラップの回収前工程の分離、剥離、濃縮処理技術であり、当社は独自のシンクプロセスで開発を実施してまいりました。次に大切なのは、前工程で分離した金属の純度を高める生成プロセスです。生成はメタルの高純度化を意味しますが、こちらにつきましても当社独自の技術を開発してまいりました。例えば通常の工業レートで使用されるルテニウムの純度は 99.95% ですが、当社は半導体グレードで使用できる 99.999% まで高純度化ができます。またこの処理量に関しましても、イリジウムは年間7トン、ルテニウムは年間25トンと世界最高レベルのキャパシティを有しており、お客様への安定供給を支えております。フリア金属はグリーンメタルのポテンシャルを最大限に引き出す技術開発と安定的有効に再利用するためのリサイクル技術開発に努め、美しい地球を守り、人類がより良い環境で生活できるように大きく貢献してまいります。本日は誠にありがとうございました。
Thank you, Mr. Furuya, for your detailed presentation. We know that Furuya has been involved in highly specialist PGM material applications, such as sputtering targets and catalysts, for some time. When did you begin to be involved in the hydrogen economy?
はい、当社は2005年くらいから燃料電池や水電解用灯向けの材料開発を開始しており、低地燃料電池向けのルテニウム触媒材料や水素ステーション向けイリジウム系材料などで大手自動車メーカーに実績があります。
Can you provide us with an idea of how Furuya is approaching the business opportunity of hydrogen? For example, in terms of the manufacture of catalyst materials for proton exchange membranes, is your focus mainly on electrolyzers only?
はい、水の電気分解触媒の分野に関してましては、イリジウム系材料開発とリサイクル技術の開発に大きく力を入れております。また 電気分解だけではなく光触媒を活用した水電解などの次世代技術への展開が見据えた材料も開発も着手しております。
Do you see Furuya's future role as providing a tailored solution for individual electrolyzer manufacturers, or more the provision of a standardized multi-customer product?
個々のお客様の視点に合わせた材料提供は必須でございますが、基本的な材料構成は共通した業界標準的な材料を幅広いお客様に展開していきたいと考えております。
Given the small size of these rare metal markets, how significant to Furuya's business is recycling at present? As a refining company, do you offer open-loop or closed-loop recycling services?
はい、大体 40% です。現在はクローズドループのリサイクルがメインですが、今後オープンループビジネスに展開していくことを考えております。特に生成回収につきましては、フレア金属はリスクを冒し、まだ市場ができていない中で、今鉱山会社が生産する規模のリサイクルシステムを構築いたしました。
The platinum group metals industry is used to collecting and recycling spent auto catalysts from vehicles. Do you see something similar for PEM electrolyzers at the end of their operating lifetime?
はい、もちろん使用後触媒をリサイクルすることを前提に考えております。PEM 水電解は自動車と比較すると触媒の集荷量が容易でありますため、問題なくリサイクルできるものと考えております。
Primary supply for these mission-critical metals, such as platinum, ruthenium, and iridium, is geographically dominant in South Africa, and as such, we notice that South African producers are minority shareholders in Furuya. Will you be asking the producers to join you in unique joint ventures to unlock and roll out further hydrogen adoption technologies?
はい、フリエ金属は今まで PGM 特化した仕事をしてここまで発展成長させていただいております。脱炭素水素社会現実には PGM は不可欠であります。また脱炭素水素社会実現は一社ではできません。PGM 生産者を含めた異業種企業と弊社のアイデアを技術を持ち寄ってみんなで協力しながら進めていくことが必要不可欠と考えております。特にフリア金属は PGM 特化した仕事をしております鉱山会社またお客様フリアがお互いウィンウィンの形で環境に大きく貢献するような仕事をこれからも力を入れて進めていきたいなというふうに考えております。
古谷さん、ありがとうございました。
どうもありがとうございました。PGM で世界一を目指すフリア金属です。サンキューガイア。
Our final eminent guest speaker today, Mr. Neal Froneman, is the Chief Executive Officer of Sibanye-Stillwater, the largest independent producer of the critical metals for the hydrogen economy. Over the past 8 years, Mr. Froneman has led the transformation of Sibanye-Stillwater from a major South Africa-based gold producer into a leading critical metals miner ranking among the world's top 3 PGM producers. In addition to being a supplier of these metals into the wider net zero market, Sibanye-Stillwater's commitment to excellence in environmental, social, and corporate governance aims to result in net zero carbon emissions by 2040. The company is already active and well-placed in the hydrogen economy, with substantial investments and partnerships across renewable energy, materials development, and recycling. Mr. Froneman will explain how producers such as Sibanye-Stillwater will help to ensure the responsible and effective supply of the green metals required for hydrogen production. The quote I have for Mr. Froneman is, "The materials of wealth are in the earth, in the seas, and in their natural and unaided productions." よろしくお願いします。
Thank you for that very kind introduction, and ladies and gentlemen, good morning and good afternoon, depending where you are. It's indeed a pleasure for me to join such a distinguished group of speakers at this conference. As you can see from the title of my presentation, I also hope to demonstrate Sibanye-Stillwater is committed to becoming part of the solution and a leader in arresting climate change. So I look forward to delivering this message. Moving on to the first slide. This is a disclaimer. There are a number of forward-looking statements in this presentation, so please take note of this safe harbor statement. Moving on to the next slide. And I always believe it's important to start with strategy, and on this slide you will see the Sibanye-Stillwater three-dimensional strategy, and I believe that this distinguishes us in the metals and mining space. I'm not going to go through the strategy in too much detail. It's really what is relevant to this conference that I will highlight. So our strategic foundation is very important to us. Our purpose is about global sustainability through our metals and energy solutions. Our vision is about being a leader in shared value for all stakeholders and climate change reversal. Embedding ESG and shared value as the way we do business is important, and I will show that to you. And then, of course, our values, and we always talk about our CARES values, and CARES stands for commitment, accountability, respect, enabling, and safe production. Moving to the right of the screen, and what is really relevant to this conference and to my presentation today are the issues under our strategic differentiators. Now, first of all, core to that is being a force for good, and I certainly hope that by the end of this presentation you understand our commitments in being part of the solution to climate change and to assisting the hydrogen economy in terms of the metals that it requires. We have a strategy of building a portfolio of global green metals and energy solutions that reverse climate change. There's a combination of battery metals, uranium for nuclear energy, and of course I will focus more on the PGMs, which underpin our green metals strategy. Just to complete the strategic differentiators, we are an organization that believes very strongly in the importance of people. We're inclusive, diverse, and we are slowly but surely becoming more bionic in what we do. In other words, incorporating technology, being a digital-first organization, and of course using artificial intelligence. It's also very important for my messaging today, and I think for the regionalization of supply chains, that the area that is highlighted as growing our involvement in pandemic resilient ecosystems is important.
we are not just a contract miner. We're a company that believes in partnering and being involved in the downstream side of this business. And again, I hope to highlight that to you as we go through this presentation. So moving on to the next slide. And this slide is titled A Force for Good. And it's really about our credentials and recognition. And again, I'm not going to go through every single thing on this slide. But certainly we have received a lot of recognition for our ESG credentials. We are members of important associations which are key to global institutions, and we are working towards continuous improvement. And I'll leave you to read all the achievements at your own leisure. Moving on to the next slide. This slide starts to outline how and what do we mean about building a climate change resilient business. And there are other metals on this slide, and I'll cover them shortly. I will obviously try and focus on the PGM aspect, which is important from this conference point of view. But I think as you get to understand what we are trying to achieve as a mining company, as a business, I think that you will get a good understanding of our ethos. Now, we are a South African company. We have a significant gold and PGM operation in South Africa. Of course, South Africa is well known for its abundance of PGMs. We also have a significant exposure to PGMs in the United States. We have some primary production out of the Stillwater assets that is predominantly palladium rich, but we also have a very significant recycling business that produces about 800,000 ounces a year. And that gives us, as a PGM company, one of the best geographical diversification portfolios of any PGM company. To complete the picture, we have battery metal exposure in South America. We have battery metal exposure in Europe, in Finland and France. And we believe very strongly in the circular economy, which is also important for today's and this conference discussion. And in that regard, there's two parts of our business that give us exposure to the circular economy. That is tailings retreatment, and we have an investment in New Century Resources in Australia that produce some of the greenest zinc in the world, and DRD Gold in South Africa that is involved in tailings retreatment of gold. In the US, as I've already said, we have a very significant recycling business which bolsters our PGM production out of the United States. And I'll say more about that a bit later. Moving to the right of this slide, and I'm mindful that this is a hydrogen conference, but I do need to show you where all these metals fit together in our green metal strategy. The battery metals that we refer to are lithium, nickel, cobalt, copper, and manganese, and I've shown you our current operating platform in that regard. Graphite is not a metal, but very important for batteries. We have significant recycling and tailings retreatment exposure. I've already explained that. Uranium is a byproduct of gold. Of course, what's key to this conference and to the upcoming slides that I'm going to share with you are the PGMs. Palladium, platinum, rhodium, iridium, and ruthenium. And in the future, they will be a very significant underpin to the hydrogen economy. And we want to make sure that that is sustainable and that we are part of the solution and part of arresting climate change on a global basis. So we are a unique, diversified global mining group. There is no mining company that has the combination of metals that you see on this slide. Moving to the next slide. And this is really just our journey as to how we have built this company and how we are transitioning to a greener future, which is of interest to all of us. Our base assets were in gold, and we started as a company in 2013. In 2016, we made our first move into the PGMs by buying assets that are well known to those in the PGM business: Aquarius, Rustenburg Platinum from Anglo Platinum, and then in 2019, the Longman assets. In 2017, we became an international company when we acquired Stillwater. I want to make the point that we spent 2 years planning these acquisitions before we made our first move. Similarly, we've done the same as we've moved into battery metals. Our first announcement was in 2019, and then in 2021, we've made 5 acquisitions in short order, and that's really given us the foundation of our battery metals business. But today is about the PGMs, and that's what I'm going to be focusing on going forward. So moving to the next slide. So we all know that PGMs are unique metals relevant to both clean air and the hydrogen economy. And from a sustainability point of view, the clean air business being autocats will underpin the demand for these metals. And then over the medium to longer term, of course, the move globally to hydrogen and fuel cells will, of course, result in a change in demand and a slight change in the use of these metals. And we've made it our business to understand that change. And I would like to just focus on the bottom part of that slide. Platinum, we know, is an effective catalyst for PE and electrolyzers and fuel cells. Iridium is key to the production of green hydrogen through electrolyzers, and ruthenium is used in PE and fuel cells together with platinum. So those become the PGMs that you need to focus on when you look at the longer term. So moving to the next slide. And this slide has been included just to provide some confidence to the end users and some confidence to those entering the hydrogen economy that there will be sustainability of the PGM companies, because the demand for autocats remains robust despite very significant battery electric vehicle penetration. And in fact, my view is that in most cases, the battery electric vehicle penetration is somewhat overstated. There's going to be significant shortages of battery metals. But the 2 graphs that you see in front of you, one is for light vehicle production. And again, you can see that in terms of internal combustion engines, the demand over the next 10 years remains reasonably flat once you get past the COVID issues and the chip shortages. You can see the impact of battery electric vehicles with having a 12% market share by 2025 and up to 22% by 2030. Fuel cell electric vehicles actually grow to just over 1% share by 2030. Obviously, that's not a key component, but it's important. When you look at the heavy vehicle production forecast, you can see it does increase slightly you can see the role of internal combustion engines remains pretty significant. You can see that both fuel cells and battery electric vehicles will have a similar share of that market. So out until 2030, and why 2030? Well, we see significant changes in the demand for PGMs from the end of this decade on, and that's really driven by the growing hydrogen economy. So moving on to the next slide. And again, I'm not going to dwell on this because there are experts in the panel that understand this side of the business better than we do. But what this slide does show you is the ease of switching to hydrogen and the advantages of hydrogen are well known. And that's outlined in the block or the matrix on the left-hand side of this slide. So residential heating, high-grade heating, regional transport such as trains, heavy vehicle, and of course steel making are significant advantages in terms of the use of hydrogen. If you look at the graph on the right-hand side, again, you can see some detail in terms of the costs and the break-even costs of hydrogen related to different segments of the economy. So the point is that longer-term demand for green hydrogen is driven by hard-to-abate industrial applications beyond our forecast period of 2030. So we have significant confidence in the future of the hydrogen economy. Moving on to the next slide. And again, I think this starts focusing on the differences between the different PGMs and their demand now and those in the future. It's well known that iridium in electrolyzers becomes a significant requirement beyond 2030. And that's outlined in the pie charts on the left-hand side. You can see the increase in planned projects from 2020 to 2030, and you can see how that increases from 21% right up to 69%. The right-hand side of this slide makes the point that thrifting is vital for cost reduction and technology sustainability. We saw that in AutoCats, and it is the right thing. We don't want to be wasteful. We've got to get the costs down. We understand the costs for a 1 megawatt PEM electrolyzer, moving from full system to stack to CCM, and that's outlined in the cost breakdown below it. I think the points that need to be made is that iridium and platinum contribution to CCM can be significant depending on price, but it's relatively a small part of the overall cost. Scope for other costs to decrease more with scale up are real. So it does put iridium and platinum in the spotlight. And of course, as a good partner, we would want to make sure that we can produce these metals at the lowest possible cost with a fair profit. So there's lots of opportunity for the industry to collaborate, to align with iridium demand. We are one of the biggest producers of iridium, and we've been through the cycle of thrifting. We've been part of using substitution to assist OEMs to reduce their costs and ensure sustainability of our businesses as well. And we would be happy to be part of recycling and developing open loop systems with the end users. Moving to the next slide. And again, this just gives you a bit more detail on the anticipated demand shift due to hydrogen. And you can see towards the right of the graph how you start seeing more and more usage of iridium and ruthenium. You can also see the inroads that fuel cells make from about 2026, 2027. And you can also see in this graph the reduction in the use of palladium in autocats. And this is how we run our business. This is what we will use to develop our projects to make sure that there is no short supply of these metals. We will play our role. But you can see how the minor metals become more and more relevant, and their demand increases as we move into the hydrogen future. Moving to the next slide. And I want to make the point here that Sibanye-Stillwater is very well positioned to supply the metals for today and tomorrow. And what we've done is we've looked at 2030 based on the graphs that you've seen. And we've just outlined what our 5E production ratio would be. And we've also outlined the global 5E demand ratio, and you can see as you move across this table, palladium is our production ratio is 45, global demand is 42, rhodium is 5%, global demand is 8%. But as you move towards the green, the metals used in producing green hydrogen and the hydrogen economy, you can see how we are aligned with the demand in terms of our own pool split. Our production ratio for platinum is 40%, the global demand is 39%. For ruthenium, it's 8% iridium. Our production is 2%, and global demand is 2%. You can also see the Sibanye-Stillwater share of global supply being around 20%. So we are a significant supplier, and we are committed to playing our role in ensuring that the hydrogen economy is a success and supply is not constrained. We have the right pool split. Our basket would not be out of balance, and we'll obviously be very cognizant of this when we start up any project. So moving on to the next slide. And talking of projects, this is our project pipeline, and you can see we've got a very significant pipeline. I'm going to give you some numbers right now, but you can see the different projects listed on the right. There's 20 of them, and you can see the project status between those that are being implemented, those where the feasibility study is complete, and those that are in pre-feasibility or concept phase. Now, we have reserves of 82 million ounces. That would be 5E reserves. The important point is that is only 17% of our resource base. Our resource base is approximately 477 million ounces. So we certainly have very substantial capacity both in South Africa and in the US to deliver into the demand requirements of the future. Moving on to the next slide. And this is really our production profile stacked up from our current base in South Africa in the dark blue at the bottom. The unapproved projects that you saw in the table, which we will approve as long as they're commercial and that the market conditions are right. On top of that, in the grey, you have our US PGM production, and on top of that, our recycling. I think important to note, for those of you that may be concerned about supply risk from South Africa, we have almost a 50-50 split in supply between Southern Africa and North America. So that should also give you some confidence in our ability to ensure that these metals are not in short supply. So we have significant long life assets with significant amount of flexibility, which we believe will meet future demand requirements in a supportive environment. Moving on to the next slide. And this is really my conclusion, and hopefully many of these points were made earlier on in the presentation. So we are committed to service the future hydrogen economy metal requirements. I've shown you that we have the resources to do that. We have a pool split that reinforces our sustainability, and of course in the short to medium term there's very significant demand from the clean air side, which will underpin our sustainability. So we will be around in 2030 to supply the metals that are going to be increasingly required. We are also not a company that only supplies metals. We like to work with the end users. We like to develop strategic customer relationships. We believe in creating shared value beyond just transactional selling. And from a mining perspective, what we say is we're not just contract miners. We are willing to become involved and work with our partners downstream. We believe in establishing good relationships and new ways of working. I'm sure you're already finding our approach quite inspirational and refreshing. And of course, we would like to work with our industrial customers in a value accretive way. So the bottom line is, in the longer term, the sustainability of PGM supply into the green hydrogen economy requires all value chain participants to work together, and we are very willing and committed to doing that. So with that, and the last slide is I'd be very happy to take questions. So thank you very much.
Thank you, Mr. Froneman. And now, I have some questions for you. At Sibanye-Stillwater, what excites you most about the business opportunities in the hydrogen economy?
Thank you. We believe that the hydrogen economy is a key part of addressing climate change, and have confidence in the important role the hydrogen economy will play in creating a sustainable planet for us all. We are a material provider of the metals necessary to produce green hydrogen and fuel cells, and as a force for good, we have embraced the need to ensure a sustainable supply of these metals to address climate change. Beyond 2030, we see growth in industrial applications for both electrolyzers and fuel cells, which will require substantial supply of platinum, ruthenium, and iridium. As I mentioned in the presentation, we are not just contract miners for the end users, and our business model includes developing partnerships within our ecosystem and being an overall supplier of energy solutions. We see that many opportunities will emerge to partner and work downstream as the green hydrogen ecosystem goes through formative stages, creating shared value for all of us. So in a nutshell, The moves to electric vehicles and the hydrogen economy will require a combination of many technologies, and Sibanye-Stillwater is exceptionally well placed to deliver metals for all technologies from both primary and secondary supply.
As you mentioned in your presentation, you are building a climate-resilient business by developing a unique, diversified global mining group. And your journey is evolutionary, pivoting toward a greener future. I know that you already produce the key metals, platinum, ruthenium, and iridium, for the hydrogen sector, and you are a major player in PGM recycling. Will you develop a recycling model for facilitating the recovery of these key hydrogen metals in both tailings retreatment programs and potentially start up an open loop of recycling end-of-life electrolyzer equipment and fuel cells?
Thank you, and that's a good question. Absolutely. The answer is yes, and we are already well advanced in our exposure to the circular economy with our PGM recycling business in the USA and our tailings retreatment business in South Africa and investments in Australia. Open loop recycling is key to sustainability, and my reference to the downstream ecosystems and partnerships includes this aspect. Sibanye-Stillwater is the largest recycler of spent autocats in North America, and so we really understand the recycling model, and we think the model is expandable globally. We recently acquired the Sandoval nickel refinery from Eramet. This is a fully permitted industrial site and has vacant ground adjacent to the refinery. We intend to expand our autocat recycling footprint from North America into Europe, and certainly we could do this anywhere else in the world as well. So we are looking at that feasibility of constructing an expansion to our PGM recycling business, but also battery metals in the foreseeable future.
Can you tell us some more about Sibanye-Stillwater's efforts to decarbonize its production of green metals? What are the easy parts of the process to decarbonize? What is the most difficult? For example, how will the green pivot become a serious consideration for project approval and capital allocations, given your broad portfolio of metals?
Thank you. As you would have seen in the presentation, ESG is the foundation of our strategy. I should say good ESG is the foundation of our strategy. And as I presented, developing a climate change resilient business is one of the key sustainability themes. We have committed to carbon neutrality by 2040 and believe we can achieve these goals even sooner. Our carbon emissions amount to 9 million tons per year, and we have well-developed plans for our existing operations for Scope 1 and 2 emissions. Scope 3 emissions require more work, and this is in progress. Fortunately, most of our emissions are related to the energy-intensive nature of our business, which receives power from coal-fired electricity generation in South Africa. And as such, 88% of our Scope 1 and 2 greenhouse gas emissions can be tackled by focusing on this single cause. We have renewable energy projects being rolled out, and that will enable Scope 2 emission reductions to 24%, I should say, by 2025. In other regions, we will fully transition to the clean electricity that is available in free markets and intend to transition from diesel to electric powering of mobile machinery. The allocation of capital to the green pivot is already being prioritized and is a key consideration in our M&A growth strategy.
There have always been strong links between producers and auto catalyst fabricators. It is the main use of PGMs currently and historically. How do you see that changing as the hydrogen economy becomes increasingly important? Will producers need to take greater responsibility for aligning their production menu to fast-moving, downstream decarbonized end-use markets?
The simple answer is yes, and to some extent, I alluded to this in the presentation. Fabricators are important clients, but they are not always the end users, and we need to engage more directly with end users. On the clean air side of the business, we have found that end users sometimes do not have a sufficient understanding of supply, and this leads to suboptimal long-term decisions. We've established good relationships with end users and have recently provided some of them with significant shared value, such as being an integral part of driving palladium substitution with platinum in gasoline autocats. Producers have limited flexibility to adjust their production menus, so collaboration within the supply chain and ecosystem is really the only way to ensure sustainability, and this is the model we have been driving and will continue to drive.
As iridium and ruthenium, production co-products from PGM mining and South African producers appear to be, at best, replacing depleting mines and not expanding output. What PGM prices or basket price would be needed to give the go-ahead for new projects you have referred to in your presentation?
Thank you. And from our point of view, I think that the current basket prices that we are experiencing at the moment are probably above incentive levels to justify commercial decisions or commercially approved new projects. However, there are other factors than just pricing and margin that need to be considered when making an investment decision. Most importantly, it would not be good for our ecosystem to create oversupply of some of the other PGMs, and that is why collaboration with the end users is important. We have, as I outlined in the presentation, a plethora of potential new projects, the majority of which are UG2 projects, which are richer in iridium and ruthenium. So these can be brought on stream under the right market conditions, but there is significant lead time required to bring these projects on stream, and hence my need to reinforce that collaboration in this ecosystem is absolutely necessary so that we do not end up with a shortage of metals, of key metals, and we have the time to bring these projects into production.
Finally, where do you see the opportunity to adopt green hydrogen as a fuel in your operations?
There's plenty of potential to adopt green hydrogen, and certainly on our underground trackless fleets in the United States and South Africa. However, the technology is not yet mature enough for adoption at this stage, but I have no doubt that it will get there. In the meantime, we are developing our equipment to use batteries so that the platforms are really created and ready to be modified to run on hydrogen in the future. Battery capacity and charging time is a big constraint at the moment as well, which is where we think hydrogen will have an advantage. We're also keeping a close eye on the technology readiness and we will continue to investigate thoroughly. So that's one aspect. We also rely on significant logistics and fleets of vehicles on surface, more specifically in the South African region, that would be amenable to hydrogen as a fuel source in a region with low infrastructural maturity, as they run fixed routes in a specific area. We expect green hydrogen in South Africa will reach commercial viability perhaps sooner than in most other jurisdictions due to the favorable conditions for renewable electricity generation and advanced bulk infrastructure. Our latest acquisitions in Brazil also lends itself towards the use of hydrogen in the pits in the short term, once we are comfortable that the technology is ready for implementation.
Thank you very much for answering all my questions. Today's presentations have provided us all with a fascinating insight into how leading figures can trigger the sustainable offset of the global warming. Through sound state policy, hone hydrogen adoption, and the timely mission-critical deliveries and refinement of Earth's platinum group elements. So, I would like to leave you with these thoughts. Nothing living should ever be treated with contempt. Whatever it is that lives, a man, a tree, or a bird, should be touched gently because time is short. Civilization is another word for respect for life.
Thank you, Gaia. Your mother-like presence and all-nourishing comments have provided us with much food for thought. I would also like to thank our excellent speakers today, and in particular, our conference partners in Japan, Furuya, and our shareholder, Sibanye-Stillwater, for its sponsorship of this event. Finally, thank you to all our event organizers, DNA and the SFA team, both in Japan and Oxford. I will leave you today with this thought-provoking quote from the English essayist and literary critic, William Hazlitt. We do not see nature with our eyes, but with our understandings and our hearts. Thank you.